warahmatullahi wabarakatuh, and very good morning. Today we are from group 6 and we are going to present about control system, the stability of the missile control system, okay, which is closed loop control system. Okay, my name is Muhammad Ashraf bin Nasruddin, metric number 174877. Okay, next. Introduction. The flight control system is one element in the missile homing loop. It controls the inertial missile motion and use effectors to force the missile to track string commands to achieve a target intercept. Okay, the input to the guidance law is the estimation of the LOS angle rate formed by the state estimator. The output of the guidance law is the string command, which is translational acceleration. Okay, this is like the diagram of the missile. You can see that a few of the sensor, the flight path to the target, radar, and here is the stabilization feedback. And the control system for the stabilization is around here. Okay, next. Okay, the important parts of a missile needs to have excellent performance are first the airframe and control surface. And then the second one is the propulsion system, and the third one warhead system, and the fourth guidance and control system. Okay, how do a missile control system achieve stability? Okay, of course we need stabilization, and it is a feedback, it is closed loop. Okay, system rate gyros and then the accelerometer are the sensors that we use in missile. Okay, input, motion of the missile and guidance signals. Okay, general effects of the damping to avoid any tendency of the missile to move from the desired course, which is not to let it go away from its path, and then to prevent or minimize overshooting and oscillation when the missile is maneuvering in response to guidance command signals. Okay, type of sensor. The first one is the gyroscope. It's been used in aeroplane to achieve the stability. Okay. It produces rate voltage output sent to the servo amplifier to help stabilize the missile motion about the center axis. Okay, and then this one is the accelerometers. It's used to detect and monitor vibration in rotating machinery. Okay, you can see that accelerometer is in here. Next one. Next. Okay, to Chong to continue the presentation. Thank you.
My name is Chuan Zhong, machine number 171805. Now I want to present about the diagram of missile. So this is a diagram of missile, and the purpose of our control project is one to determine the control section of this part, which is this three plate is control the stability of missile. So now I want to present about. Okay, now I want to talk about the conceptual block diagram of our control system. Now, from this, our tracking data will come to A or B, and will go to the computer. And the computer will give the signal to DNA, and straight to the amplifier K. The amplifier K is the how to say that? Is the shape of the plate. And finally, we'll go to airframe dynamic. And we have a sensor called accelerometer will detect the acceleration of the rocket and give feedback to computer. Next. So we now want to talk about the block diagram, and in our program, in our computer, we will have one equation which 1 minus exponential minus Ts over x. And we will have amplifier and airframe dynamic equation 15 over s times s plus 15, and the accelerator will give feedback to the computer. Next. So this is a similar block diagram, which is the only difference is we move our sample to here. So that means from the previous block diagram, we will have two samples here. That means we call it on-off switch between here, then we combine together, we put into that. So these two block diagram is similar, and the reason why I want to put second the block diagram is because they will help us to more, I would say, more understand about the control system, and will how to say, like, we will make our calculation easy. Okay. Now I will proceed to myself to second part.
Assalamualaikum. My name is Maisara binti Ahmad with matrix number 1744052. So I'm going to explain about transfer function for our missile project. So for our project is to find the transfer function and stability for this system. When A is given 15 and t equal to 0.2. So from the block diagram, you can see the A is 15, and this is the transfer function that we can obtain from this block diagram is this one. GS from S plane, GS equal to 1 minus E exponent to the power negative PS over S times 2KA over S multiplied by S plus A. So to transfer the S plane to Z plane, the transfer function that we can obtain is dz equal to 1 minus z to the power negative 1 multiplied by z and multiplied by Ka over S square multiplied by S plus A. So then we calculated as this one, and from this we have to find the partial fraction, and like this equal to A. Then to find the partial fraction for A, B and D, for B, C and D, we assume when S equal to 0, then we obtain B equal to 1. When S equal to negative 1, we got C equal to negative 1 over A, and when S equal to negative 1, we obtain B equal to 1 over A. So we substitute to the transfer function where Kz multiplied by 1 over S2, this is B, C and D. Then we get the transfer function for Z plane. Then we substitute the value of T and A in the Z plane transfer function. Then we get this form of equation. So from this we can obtain the transfer function for our closed loop digital missile project. So to determine whether our system is stable or not, we were given K equal to 17. Then we find the root to see whether our system is stable or not. Then we obtain this pole Z equal to negative 0.64 plus minus J 0.74. So the system for K equal to 17 is stable because both of the poles are inside the unit circle. But when K equal to 50, we get 0 equal to negative, Z equal to negative 0.41, and the other one pole is negative 5.0, which is the system is unstable because one of the pole is inside the unit circle. Outside the unit circle. So that's it for me.
Assalamualaikum, my name is Sister Amalina Tiaya and my mention number is 17431. Okay, I will explain about the MATLAB for this system. First of all, from my Sarah parts, which is for transfer function, and my parts is for the MATLAB of the transfer function. Okay, from the day. So with the diagnosis to define the denominator of GAS. So we define is 1, 15 and 0. 1 is the S and 15 is the A. After that, we use MATLAB for 4, which is K equal to 1 until 25. And then the TZ is the feedback, which is K times GZ, 1. R equal to pole, which is TZ. From this we can get the poles of the value of K. And then which is Rm equal to max times epsilon R, which is we find the pole with maximum epsilon value for K. And then when Rm are equal to greater and equal to 1, which is the poles is outside or inside the circle, and then we break, which is to stop the pole is found outside the circle or inside, and then n if and n4, and then the value of K and R will display after the calculation. Next, from this is the answer from the MATLAB. And we find is the GA is equal to 15 over S square plus 15, S 15, which is in the equation that my Sarah transfer function that my Sarah explained. And then we find that GZ equal to 0.1367 Z plus 0.05339 over Z square minus 1.05 Z plus 0.04979, which is for the transfer function that we found, that we calculate. And then the sample time is 0.2 second. And after we run the MATLAB, we found that the maximum K for the value for this transformation is 17.8. That's why if we use K more than 17.8, the poles will be outside the circle. And the R that we find is the poles. R equal to poles, okay? Poles for 17.8 is 0.96913 plus minus 0.72261. Okay, that's all. Okay, next. That's all for me, and we will continue with Amalina.
Okay, my name is Amalina Terosdan, with number 174S79. I will further this discussion about missile control system. So in this discussion, we are asked to discuss about the working principle of missile control system. So the system that for missile is named as missile flight control system. We focusing on how the missile control its direction. So in missile flight control system, is known as one of element of closed loop control system. The direction of missile is controlled by the target and position of the missile. So for the initial missile motion is controlled by the flight control system. It also controlled by the one sensor named as IMU. So this inertial missile motion combines with the target motion to form the relative geometry between the missile and target. So basically the control system for missile is focusing on the geometry, direction and also target tracking data. So next, from the block diagram, so for this block diagram that has been presented before, is a system that focus on tracking data. It's actually a phase for tracking data of the motion, direction motion of missile. And the figure 3 is 4 basic elements of the flight control system, which is consists of aerodynamic, sensor, actuator, and also controller. So the first thing in system is actuator. Actuator turns the autopilot command into physical motion of control effect. This autopilot influences the airframe dynamics to track the guidance command. And the next component is missile control electronic. It actually a type of controller. This control electronic provides a super cache amplifier for each of the missile interfaces. So this controller assists the seeker gyro control circuit of the missile. This controller has the gyroscope principle. So for this controller, the function is to maintaining the gyro axis in alignment with the missile longitudinal axis. So the next component is sensors. So there are two types of sensor for these missiles. First is accelerometers. Accelerometers function as to detect and monitor vibration in rotating machinery. And the second one is terminal sensor. This terminal sensor measure the missile to target to line of sight LOS angle. So yeah. That's from me. I will proceed with Joe.
Okay, my name is Zhao Xiaoxiao. Student number is ES00669. I will say conclusion. Here are the stabilization of inputs and outputs of damping device. The stability analysis of missile control system using low-skew prediction is done successfully. The digital control system is unstable if any fault is outside the unit cycle under the plan. Technique will continue to evolve to realize better stability of missile control system. That's all. Thank you.